Okay, hello everyone. Let me introduce myself. My name is Sabrina Maulida and my last number is 153. So in this video, I want to discuss about the injective, surjective, and bijective function. I think before we discuss about the injective, surjective, and bijective function, we must know about the definition of the function. So what is a function? A general function points from each member of A to a member of B. It never has one A pointing to more than one B. So one to many is not okay in a function. So something like fx equals 7 or 9 is not allowed. But more than one A can point to the same B. Many to one is okay. So after we learn about the definition of a function, let's move on to the injective function. Injective function means we want to have two or more A's pointing to the same B. So many to one is not okay, which is okay for a general function. As it is also a function, one to many is not okay. But we can have a B without a matching A. So you can see in this picture, A cannot have more than B, and B can also have no A. So the formal definition is for every x1, x2 in df, which is df is the domain, x1 not equals x2, implies fx1 not equals fx2. So injective is also called one-to-one function. I think to make it easier for you to understand, let's move on to the example. So I have a function fx equal 3x. We must to prove is the function is injective function. So to prove that function is injective, we have to take any x element real, such that x1 not equals x2. I choose x1 is 1 and x2 is minus 1 because I think it's the easier number to calculate. So fx1 not equals fx2, 3x not equals 3x. And then we substitute this x1 and x2 to the function, to the x in here, and we get 3 not equals minus 3. So because this value is true, so this function is proven. We can say that fx equal 3x is an injective function. So other way to proving, you can use GeoGebra. If the graph is like this, it's called injective function. So the second one is surjective function. Surjective function means that every B has at least one matching A, maybe more than one. You can see in this picture, B at least have one matching A. But there won't be a B left out. So the formal definition is for every Y element real such that X element df, df is the domain, there exists Y element fx. So I think let's move to the example. So we have this function fx equals x squared. We must prove this function is surjective. So to prove this function is surjective, first take any Y element real. We change fx to y. So y equals to x squared. So x equals to root of y. Now we substitute root y to fx. So we have y is equal root of y squared. So the value is y equal to y. So it's proven. So it's proven. And we can say that that function is surjective function. So you can prove it by GeoGebra. So if you see graph like this, you can say that the function is surjective. Okay, the last one is bijective function. Bijective function means both injective and surjective function. Think of it is a perfect pairing between the sets. Everyone has a partner and no one is left out. So there is a perfect one-to-one correspondence between the members of the set. You can see in this picture. Yeah, it's perfect pairing. Every A have B and no one B is left out. So let's move to the example. We have this function fx equals x power of 3. So to prove this function is bijective, we have to prove that the function is injective and surjective. So in my opinion, I think we should prove the injective first because it's the easier way. So take any x element real such that x1 not equal x2. Choose x1 is 1 and x2 is minus 1. So we have this 1 and minus 1 for the value. Because x1 not equals x2 is proof that the function is injective. The next step, we have to prove that the function is surjective. Take any y element real. So we change the fx to y, and then we have cube root y equals x. So we substitute the value to the function. And then we have y equal to y. So it's proven that this function is surjective. So we can say that the function is bijective function because it's injective and also surjective. So you can still using GeoGebra to prove the function. So the graph is like this. If you see the graph like this, so the function is bijective. So I think that's enough for me. If there are any mistake, I'm so sorry. And if you have any question, you can email me on snmririn@gmail.com. So thank you guys for your attention and see you in the next video. Bye bye.